We're going to take a look at translations to the right or left with a family of graphs. And let me explain really quickly what we mean by a family of functions. And let's just say, for instance, I have this. Let's take a familiar graph, like a parabola, f of x equals x squared. If I actually see this, some coefficient to the front, some type of adjustment inside the parentheses, and then some kind of adjustment tacked on to the end, these are actually transformations to what we call the parent graph, the basic parabola. And you notice that you can find the basic parabola sitting right there. The yellow adjustments are just transformations. This happens to be horizontal. This we know as vertical, and this right here is a shrink or stretch and sometimes a reflection thrown in there. So what we're going to take a look at is just translations that are horizontal in this first video here of 2-3, and we're going to talk about just left and right. Now these are what we call rigid translations, rigid transformations, and that just means that it's not going to morph. The shape is going to be the same. We're just going to be sliding it, if you want to think about it that way. That's the way we're doing it. So let's go ahead and get the basic graph, the parent graph, we call it, onto the coordinate plane. Now I'm going to obviously not be able to use any negative values into that x because it would give me an imaginary number. I'm going to go ahead and start with zero. Square root of 0 is 0, so that's fine. I'm going to go ahead and pick some numbers that will be really helpful for my square root function. So square root of 1 is 1. I'm going to skip to 4 because the square root of 4 is a nice neat little 2, and then the square root of 9 is 3. I'm going to go ahead and plot these points. Let me move this up a bit. By the way, it says to graph on the same coordinate plane, so we'll be able to tell very easily what transformation has happened. And then 5, 6, 7, 8, 9, up 3. Alright, so our graph looks like this. It's curved, and it continues to rise, and it continues to get larger in the positive infinity direction. And this is called the square root function. Now, let's take a look. And then, by the way, this is the principal root, right? The non-negative principal root. In other words, I'm not allowed to just put a plus minus anytime I want to. If I see the radical already there on the paper, then I'm going to have to use what they use, which is the non-negative version. Okay, let's go ahead and take a look at what the red one would do. Now, I want you to notice something. In order to get this underneath the radical, the expression under the radical, back to 0, you realize that we would have to start with 1. We'd have to start with 1, and that would get us back to the y value of 0. Okay, I'm putting in a positive 1. Okay, if I put in a 2, 2 minus 1 is 1, square root of 1 is 1. That gets me to that same y value of 1. But I'm going to have to put in what am I going to have to put in for the 4? Instead of 4, I'm going to have to put in a 5 just to get it to subtract 1 and be a square root of 4, which is a 2. And then I'm going to have to put in a 10 to get down to my 3. Now, if you notice something, look what's happened to these numbers. They were this, and now they're this. In other words, I'm adding 1 to every one of those values. I had to add 1 to every value just to get it to land at the same height. And so that's why we say this, folks. This is a horizontal translation, and it's actually a translation to the right 1 unit, to the right, not to the left. Let's take a look. If I go over 1, I go up or down 0. If I go over 2, I go up 1. If I go over 5, 2, 4, I go up 2. And if I go over 10, I go up 3. So what's happened is that this graph of this square root function has actually shifted 1 unit to the right. You would think, again, that when I see a -1 underneath the radical, you would think it would go to the left one because that's the negative direction on the number line, right? The x-axis, but it doesn't. It goes to the right one. Okay, so that's the reason. Take a look. We added 1. We added a positive 1 to get it back to the beginning. We're going to take a look at the blue one, and then we'll be finished with this video. Let's take a look. So what are we going to have to put in that one to get it back to the original position? Well, we're going to have to put in a -4. Alright, then we're going to put in a -3, and that's going to give us a 1 under the radical, and that square root of 1 is 1. Okay, you notice what we're doing. Think about from the beginning, what are we having to do? We're taking every x value and we're doing what? We're actually subtracting 4 from it, aren't we? So if I put in a 0, then that's going to give me square root of 4, which is 2. And I'm going to put in a 5, and I'm going to get a 3. Alright, so if you look at what, whoops, wrong one. If you look at what has happened there, there we go. Come on now, erase. Okay, so this is actually a horizontal translation. It's horizontal. It's this way, right? One left or right, but it's actually moving specifically to the left 4. So let's take a look. -4, 0, -3, 1, over 0, up 2, and over 5, up 3. And there it is. Alrighty, so I hope this is helpful. These again are horizontal translations. That just means it's a slide, and hope this was beneficial to you. Thanks for watching.